Now, moving on to the most important part of this lesson is the Kirchhoff's law. So, we've got two Kirchhoff's law, that is Kirchhoff's first law and Kirchhoff's second law. These both have different names which you need to have a part of. So, Kirchhoff's first law is known as your junction rule or Kirchhoff's current law, and Kirchhoff's second law is known as the loop rule or Kirchhoff's voltage law. Now, in Kirchhoff's first law, it's very simple. The algebraic sum of currents at a junction is 0. In this case, these two are in the same direction. These are on one side and these two are in opposite directions, and these two are on one side. Algebraic sum is same, so I1 plus I2 minus I3 minus I4 minus I5 will be equal to 0 is exactly what this law is trying to tell us. That is, summation of I is equal to 0, and that the incoming currents is equal to the outgoing currents. Now, this law is based on the law of conservation of charge. This law is based on the law of conservation of charge. Very easy way to remember: C for charge, C for current, both are CC. So yeah, that makes you feel better. Moving on to Kirchhoff's second law, known as loop rule or KVL. It is a pretty simple law, but this is the more important law of these three because it's a very numerical based law. Now, in closed loop, the algebraic sum of EMF is equal to the algebraic sum of product of resistance and current, and it is based on the law of conservation of energy. Now, this little table-ish thing which I've made you is a very important thing for your numericals, in which numerical sign convention. So your question would basically be given in this format, and you have to start the question in which they might ask you to find the total current in each resistor. So the first step which you would be doing is taking your loop as clockwise. Now, if the resistor is opposite to the current flow, it is positive. If it is along the current, it is negative. If EMS is from negative to positive, you would take positive, but it's from positive to negative, you would take negative. I just want you to remember these points now. When a numerical comes, I'm going to be explaining it based on this little sign convention table which I've made here. Please take a note down of this.